Okay, so this mini lecture is going to look at the interaction of charged particles. So how do charged particles interact? Now, you may recall from a previous mini lecture, and if you haven't seen that, go back and check it out, that we talk about 3 states of charge. So those 3 states of charge, as a reminder, are neutral charges, we're going to define as an N, a positive charge, and negatively charged particles. So what we're interested in is how would charged particles of this nature interact with one another? What happens if I put 2 positives together or 2 negatives together, or a positive and negative, or neutral charges? What does that interaction look like? So first, let's look at what happens when we have 2 positively charged particles interact with one another. So we have positive charge A and positive charge B, and they're brought close together. 2 positively charged particles will repel one another. They will push each other away. They do not want to be near each other. They will push each other away. Positive charged particles don't like each other. Similarly, if I have 2 negatively charged particles, they too will push each other away. Negatively charged particles also do not like each other. They repel. And if we generalize this idea, we find that like charges, charges of the same sign, repel with one another. What about neutral charges? What if I put 2 neutral charges next to each other? Do they repel? So I have a neutral charge next to a neutral charge, and they just sit there. They do nothing. There is no interaction between 2 neutral charges. All right, so like charges repel. One way charged particles interact. Well, what if I have opposite charges? What is our interaction between a positive charge and a negative charge? Well, in this case, positive and negative charges attract one another. They like each other. They want to be close together. They pull each other towards the other. So opposite charges will attract. Opposite charges attract. What if I bring a neutral charge into the mix? So what happens when I have a neutral charge and a positive charge? Or a neutral charge and a negative charge? Well, this is a very interesting phenomenon. Neutral charges attract to both positive and negative charges. In both cases, a neutral charge will attract. Well, why is that? So let's look at that a little bit more in depth. Why is it that a neutral charge will attract to both a positive and a negative charge? So yeah, erase the board real quick and look at this interaction a little bit more carefully. When we look at this interaction, we're going to remember that neutral objects are made up, as everything, of neutral atoms. So the atoms in all of these objects that are neutral have the same number of protons as they do electrons, and neutrally charged. So let's imagine we have a charged particle, and we're going to use the example of a balloon. So let's take a balloon and we're going to give it a charge. All right, almost done with this erasing stuff. Okay. That one's thick. Okay. So let's take a balloon. And we're going to put a charge on there. We're going to put a negative charge on this balloon. So I'm going to add a bunch of electrons to that balloon. Now if I imagine putting that balloon with a negative charge next to a neutral object, and maybe you've done this before, maybe you've taken a latex balloon and rubbed it on your head, and we'll talk about how that charges the balloon, and then you went and stuck it on the wall, and it sticks there. There's an attraction there. So what happens? Well, here's my negative charge, and here's my wall. And the wall's neutral, and it's made up of a whole bunch of atoms, and those atoms are neutrally charged atoms. So we're just going to model them as having these little pluses and minuses. And those pluses and minuses are all throughout the wall, and they're even along the edge of this wall. And if I add up all the pluses and all the minuses, I get equal numbers. So I have a neutral wall. Now let's take this balloon and move it towards that neutral wall. So here's my balloon again with all its negative charges there on the side. And now I put it right next to that neutral wall. Well, there's a few charges here next to the balloon that really like that negative side of the balloon. And so the positive, what we see is the positive sides of those molecules within that neutral wall rotate the molecule, adjust it just slightly so that the positives, because opposites attract, the positives are attracted to the negative charge that's on the balloon. And that force, which we're going to talk about, or that is talked about in the mini lecture on the electric force or Coulomb's law, that force exists between these positive sides of these molecules and that negative charge on the balloon. And the balloon will stick to the wall. This process of neutral objects attracting to positive or negative objects by manipulating those molecules inside so that the positive charge or the negative side of the molecule is closer to the charged particle is what we refer to as polarization. So we can use polarization to describe why neutral charges attract to positive or negative charges. Neutral objects, attract to positive or negative charges. There's a really cool experiment you can do with getting a charged particle like a balloon or brushing your hair on a dry day and putting it towards a neutral stream of water and having that water bend towards that charged particle. There's a great video in the Hopped Up on Physics playlist, Fun Physics, the Fun Physics playlist, Fun Physics Shorts. And so check that out on using this idea of polarization to bend water. All right, so interaction of charged particles, summary, likes repel. So like charges repel. Opposite charges attract. And neutral charges attract to both positive and negatives through this idea of polarization. All right, good job.